Okay, this is number 5 from the resistance circuits. The picture over here is shown. I've got the currents for each little strand already labeled. I1 goes, I'll call this A, call this B. So I1 goes from B around to A like this, so around like that. I2 goes from A around to B this way, and then I3 goes from A to B down straight through. So I'll get rid of that. We talked about that a little bit in class. Alright, so I'm going to go straight into the currents. So when I look at the nodes, remember A is a node, B is a node. Coming in to A is this I1. Remember that nodes in is equal to out. So coming in, I've got I1. And then going out, I have I2 here. It's leaving like that. And then I3 leaving like that. So come back to blue. So in is equal to out, which means that I1 is equal to I2 plus I3. I could do the same thing with B, and if you have done that, you've probably noticed that they're the exact same thing. Just kind of written a little backwards, but they say the same thing. They have the same relationship. So this is one of my equations that I'm going to work with. I'll star it. I need to find 2 more. And the next 2 are going to come from the loop equations. So I'm going to look at going through here. I'll call this loop 1. So loop 1, I will start right here. I'm going to go around the loop. I'm going to go through the 360, the first 360, this one, the next 360, this one, and the last 360, that one. The key here is that with the first one, I get I1. With the second one, I get I3. And with the third one, I'm back to I1. And remember, let me erase this real quick. For these loops, I use V equals IR, and I add as I go along. So the first one is my voltage is 120, so I get 120 equals, I get this combination right here. So I get I1 times 360. So 360 I1. Then I go through this one, which is a 360, but notice instead of an I1, it's got an I3. I'm going with the flow. Notice the arrows are going that way. So I don't need to make it negative. So I get plus 360 I3. And then I do this one here. That's I1. So I get plus 360 I1. Collect like terms. I get 120 equals 360 and 360 gives me 720. And that's I1, so that's this term and this term, plus 360 I3. Make that look like a 3. There we go, a little better. Alright, so that becomes another equation to go along with this one. So I've got equation 2. Maybe I'll underline them. Underline, underline. Okay, the last equation, let me erase this stuff. Get it out of the way. So notice this next loop, which I'll call loop 2. Loop 2 right here doesn't have any kind of power source in it like the 120 over there, so the voltage change on it is 0, so I write 0. This is using V equals IR again. Now I'm going to go through sequentially. So I've got 144 I2, so and then I'm going to actually have 144 I2 again and 144 I2 again. So I'm going to have 3 of them 144 I2. And then notice as I'm going counterclockwise here, I'm going up this 360 for the I3, but I'm going against that current right there. So what I need to do is make it a minus. So I make it minus 360 I3. When I multiply out, I get 0 equals 3 times 144 is 432 I2 minus 360 I3. So I'm going to come over here to the right. So my three equations that I'm going to use are that last one that I just got, this one, and then the two that are underlined in red again up top. So, see if I have enough space here. I'm going to go across the top. Actually, so here, the bottom two, the last two that I got, are a little bit easier to get the into the RREF mode. With this one, I have variables on both sides, so I need to move everything to one side. I'm going to move this term and this term both over to the left-hand side by subtracting them. That's going to give me I1 minus I2 minus I3. I'm left with nothing on the right-hand side, so it gives me 0. So now what I'm going to do is I'm going to take those three equations and turn them into a system. So actually going to give myself a little more space here. So I'm going to have an I1 column, an I2 column, an I3 column, a bar, and it closes. I have enough space over there. Alright, so the first one I take directly off this. So I get a 0 on the right hand side, and then I get 1, minus 1, minus 1, and those go with the corresponding I1 has a 1, I2 has a minus 1, I3 has a minus 1. Now I'm going to go off this equation. Remember the bar in this matrix kind of represents the equal sign? So I almost need to switch the left-hand side and the right-hand side in my head. I'm not going to rewrite it out, but I get a 120 on its own without a variable. Then I get 720 with I1. There's no I2 term, so I get a 0. And then I get 360 here. The last one, so that represents this equation right here. The last one, same thing. Switch it, get a 0 on the right hand side. There's no I1 term here, so I get a 0 here. I get 432. And then I get minus 360. Sorry, it's a little jumbled. Now I need to plug this in my calculator. I'm going to plug it into a matrix that's 4 wide and 3 high. Make sure you get that minus 360 in that last row. I'm going to RREF it. I don't have enough space on here to show the work. I would get a new matrix out of it. This gives me, I guess I'll scroll down a hair. Do it right like this. This gives me I1 equal to, and all these are in amps, 0.131 amps, comma I2 equals 0.060 amps. You should write amps, I'm running out of space. And I3 equals I3 gives us 0.071 amps. So that's my answer right here. And if you look, back up at the top, that seems reasonable. For one, the I1, which is this one here, which is this one here, should be bigger than the combine of this one and this one because of the in minus out. Notice I get 0.131 and 0.60 and 0.71, so that's true. Secondly, this part right here had a total resistance of 432, and this part right here has a total resistance of 360. They're relatively close, and they're kind of divvying up this input here, so that makes sense that they're about the same. In addition to that, I get the I2 being a little bit smaller. The I2 is the one around this way, which is the 432. 432 has a higher resistance, therefore the lower current of 0.6 versus 0.7 makes sense. Hopefully that helps. That's all.